Okay, if something goes into something evenly, right? Like we did an example the other day of like 20 divided by 5 or 20 divided by 4, doesn't matter, you can pick 30 divided by 15. If something goes into something evenly, then the remainder is 0. And so if we, this is for 8.5, if we did, 20 divided by 5, we would say, oh, the answer is 4, noting that the remainder is 0, and that's because 5 is a factor of 20, right? You could say, oh, that's, 20 could be written as 5 times 4 divided by 5, and the factors cancel, and you're left with 4. Or, we could do another one. If you had, 63 divided by 9, 63 divided by 9 is 7. And that's because 63 is the same thing as 9 times 7. So 9's cancel because the divisor and the factor up top cancel out, meaning 9 cancels with 9 because 9 is a factor of 63. So then we branched into doing something. Here's our traditional example. And if we divide with this, we've done this several times. You can do long division, synthetic division, or you could just factor. And when you factor that upper one, what you recognize is, again, that these cancel. That's because x plus 3 was a factor of the upper polynomial. And so they cancel, you're just left with x plus 2, noting that the remainder is 0, okay? So if the remainder is 0, then you know that the divisor was a factor, okay? Now, the other thing that we'll make a note of is this. Let's say we have, let's do a polynomial here. P of x equals, okay, so remainder of 0, we've got a factor going on. Let's go P of x equals x cubed minus x squared. Okay, x cubed minus x squared minus x minus 2. Okay. And let's do this. Doesn't really matter. Let's do P of negative 1. Okay. So if we do P of negative 1, this is transitioning away from doing long division or something. We're just back to basic functions. So the basic function is, if you do P of negative 1, you would just say, okay, negative 1 cubed minus negative 1 squared minus a negative 1 minus 2. And we would simplify that out. We would say, okay, negative 1 cubed is negative 1 minus 1, because negative 1 squared is 1, so minus 1 plus 1 minus 2. And so you would get P of negative 1 is equal to negative 3. All right. So the reason why we show this is, so P of negative 1 is equal to negative 3. There's a correlation to doing, just plugging in something to the function. And then there's also a correlation into doing synthetic division like this. And we would take, like we did synthetic division yesterday. This is actually called synthetic substitution, but it's the same thing. Meaning, we could have said, hey, P of negative 1, plug in, right, like we did, and you got out negative 3. Well, what happens if we do this synthetic division, except where it's not division, it's just synthetic substitution, but it's the same formatting, exact same thing, is we take our coefficients 1, negative 1, negative 1, and negative 2, and we drop the 1. If you guys were practicing this yesterday, or if you did your homework, you drop the 1, multiply, and then add, and then multiply, and then add, and then multiply, and then add, and you get out a negative 3. The correlation is this, is that you could have done P of negative 1, right? And you would have gotten out negative 3, which we did. Note that the remainder was also negative 3, meaning they match each other, okay? So this isn't like a big foundational thing, it's just making a note, okay, I could actually just do this is synthetic substitution, or I could just do function substitution. And either way, if you get out of -3 here or the remainder, they're going to always be the same. So with that, if we'll use the same p of x, okay, and then let's plug in though 2. So let's go p of 2. So we're going to do the same thing up here, but with p of 2. So we go 2 cubed, okay, minus 2 squared, minus 2, minus 2. Okay. So what that would give us is, then you would have 2 cubed is 8, minus 4, minus 4, -2 minus 4, and you get p of 2 is equal to 0. All right. So if p of 2 is equal to 0, what we know is if I were to do synthetic division or synthetic substitution with the 2 right there, all right, with our numbers, if we did this correct, which we did, what do we know the remainder is going to be? It's going to match, right? I mean, I told you that it matches, and it'll always match if we did it correctly. So the remainder is going to be 0. If something is a remainder of 0, just like we discussed previously over here, if it's got a remainder of 0, then we know that the divisor was a factor, right? 5 goes into 20 4 times evenly. That's because 5 was a factor. 9 goes into 63 evenly. That's because 9 was a factor. X plus 3 goes into this evenly, a remainder of 0. That's because x plus 3 was a factor. So if we think about that for over here, we would get out a remainder of 0 if you did the synthetic, maybe we should have done it just to make sure we see that. But you would get out, a remainder of 0. So what that tells us is this is not a factor of the polynomial. That's just a root or a 0 or a solution. If you wanted to make a connection, you would say, okay, if 2 is the root of this polynomial, this is the polynomial right here. If 2 is the root, so 2 is the root, meaning it's a 0, it's a solution, it's an x-intercept. 2 is the root. We know it's a root because the remainder is 0. So if 2 is the root, then the factor, do arrow, then the factor is going backwards, right? If 2 is the root going backwards, the factor would be x minus 2. Okay. So all this does, it actually doesn't require much from you in terms of doing anything different, except you could actually say or figure out if something is a factor by actually doing either synthetic division, if you will, right here, and plugging in and getting out a remainder of 0, or you could plug in 2 to the function, and if you get out 0 by plugging into the function, then you also know it is a factor, okay? So you could do actually both ways. If you're wondering, is something a factor, you could plug it in doing the synthetic division like we did yesterday, or now we see that there's a correlation, you can plug in the 2 there and then go from there. But remember, x minus 2 is the factor, 2 is the root. Okay, so in this, they will have this, they're going to say use synthetic substitution to find P of C. And they're going to give you this, we'll call this number 1 for us officially. They're going to give you P of x equals x cubed plus 4x squared minus 8x minus 6. Okay, so if you see this on the test, this is what they want you to do. Substitution, or just find P of C, which I'm going to give you what C is in a second. P of C, just plugging in P of C, you would do this route. There's nothing wrong with it, right? And you get out a number. Plug in P of -1, you get out a number. What they are wanting you to do is synthetic substitution. So you would just show that route, doing the synthetic division. It's the same thing. Synthetic division, synthetic substitution. You're setting up this format, okay? So with that, I haven't given you the C value that we're going to do. We're going to go C, so then they'll have this. They're going to say C equals -5. Okay. So instead of doing that, you can confirm it in case you're like, I don't know if I did synthetic division right or synthetic substitution right. You could go P of -5 and then plug in a -5 cubed plus ... right? You can do that. I'm not going to mark you wrong if you do that and you get out an answer, right? And there's your answer right here. You would need to show, though, your synthetic substitution and get out an answer this way. And so we take our coefficients 1, 4, -8, -6. And remember, whatever comes for your remainder is what P of -5 is. And so this will be your answer right there. It's the same thing. And we look here. Now the question is, do I plug in a -5 or a +5? That sometimes trips people up, but remember, it's only the opposite of the number you see if you're given the factor and then you're plugging in the root. They're not giving you the factor, they're just giving you, if you will, the root. So if they gave you x plus 5, that's the factor, then you're plugging in -5. So this is the work we would say, this is synthetic substitution, drop the 1. Now, it's not always going to work out to be, what do we get, -3 here, 15, and then 9. And so what we know then is P of -5 is 9. All right? So that's what they want, synthetic substitution. Just do this, find out whatever the remainder is, that's your answer for P of that. Okay? Fine if you confirm using this method. Okay, then, so those are pretty easy if you feel that synthetic division is easy. Those ones are really shouldn't be too bad. Here we go. Use the factor theorem, and we'll discuss. Yeah, we've talked about the factor theorem, but use the factor theorem to determine if the binomial is a factor. All right, so then we'll call this number 2, and what are they referring to? Should we pick a difficult one? Yes. Now let's start out actually a little less difficult. Z plus 2 P of Z equals Z to the 5th plus 2Z to the 4th plus Z cubed. We say an easy one. Z squared is just forever. Okay. The math isn't hard, there's just a lot of Z's in there. Z to the 5th, 2Z to the 4th plus Z cubed plus 2Z squared plus Z plus 2. Okay. The factor theorem states that if, which I did over here, if P of whatever the root is equal to 0, then it is a factor. So meaning, if we were questioning, is x minus 2 a factor? How would we check it? Well, you could just do P of 2, and if it's 0, then the answer is yes, it is a factor. Over here is x plus 5 is our root, x plus 5 is our factor, -5 is our root. Would x plus 5 divide into this evenly? Was it one of the factors of this? No, because the remainder is 9. So the factor theorem actually is this. They want you to do P of -2, and then the question is 0 or not. If it is 0, then it's a factor. If it isn't, then it's not a factor. Again, don't forget, if your factor is Z plus 2, what are you plugging in? Not 2, but a -2. And then you just plug that in using your function ability. So -2 to the 5th plus 2 times -2 to the 4th plus -2 cubed plus 2 times -2 squared plus -2. I'll show that plus 2. So a fair amount of -2's to plug in. But nice thing is you have a rusty, trusty calculator, and you can just plug that in and hit enter. Or some basic mental math, because powers of 2 aren't too bad, I don't think. So we would say negative 32 plus 32 minus 8 plus 8 plus 0. Because these would be 0. And if that is confusing for you, you can just do that. We're just doing negative 2 to the 5th and negative 32. Negative 2 to the 4th is 16. 16 times 2 is 32. And we see cancel, 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 cancel. So what does p of negative 2 equal? 0. So what do we know? Negative 2 is a root. What do we know about z plus 2? Is it a factor then? The answer is yes, it is a factor. Okay. So technically the factor theorem wants you to actually do this route, which with a little bit of calculator work is, I think, in general easier maybe than synthetic substitution, possibly. But that's all they're looking for you to do is, what is this, yes or no? I don't know, like on the test, if I say use the factor theorem, if you did synthetic division, you know, and you got out a remainder of 0, I'm not dead set on it. You have to do the function notation. Just finding out the remainder would work as well. But this is synthetic substitution. The factor theorem does the function notation plugging in. All right, so then let's do this. A root, I'm going to erase this one. A root of the equation is given. We all know what a root is, hopefully. Also the same thing as an x-intercept. A root of the equation is given. Solve. Now, we have solved many, many equations. You've solved many equations in your lifetime. Have you not? You have. Okay, so if they give you an equation, most equations we've solved, and equals 0. We'll start with that. All right, most equations you've solved have been linear or they've been quadratic. Okay, so most equations you've solved, they've been, we can use the variable z. Z plus 11 is equal to, 15. You started out solving basic equations in pre-algebra probably, maybe even in elementary school, what goes here, 4 to make it, 15, whatever. Subtract the 11, however we did it, you got to 4. Then we branched out to a little more challenging ones, z squared plus 5z plus 6 is equal to 0, right? And then we said, okay, we can solve that with, initially you learned how to do it with factoring. And so, okay, z plus 3, right? Z plus 2 is equal to 0. Z was equal to negative 2, negative 3. That one was easy to do. Then we branched out to z squared, plus 11z minus whatever, 19 is equal to 0. Then we said, oh, wow, it's not factorable, but don't worry, we have other methods. And we learned those, right? You've learned them completing the square, perfect squares, which wouldn't be, and then our go-to, which is quadratic formula. It's usually the go-to. So then we learned, oh yeah, we can solve that quadratic formula, no big deal. We did do some cubic ones. Erase this over here, but the cubic ones that you did were like this. They were ones that we said, okay, let's say you had z cubed plus 4z squared, whatever, minus z is equal to 0. And this is a z cubed, which you don't just do the quadratic formula, right? But what you could do is you could take out a z, and you'd be left with z squared plus 4z minus 1 is equal to 0. Then you would say, okay, this z was equal to 0, and then this to solve completed square quadratic formula factor, right? And then you'd be able to solve no problem with those methods. So over here, though, we look at this. This is a z cubed. Is it easily solvable? Like, oh, do the quadratic formula. No. Can you complete the square? No. Can you factor it? No. Now, you might be able to do some sort of grouping factoring, which we've done before, but usually we don't do a whole lot of grouping factoring. We learn a little bit of it and then we don't do a whole lot of it. So at this point, there's nothing you could really do to solve. You could do a calculator and look for where it crosses the x-axis. But they tell you, which I haven't given to you, a root of the equation is given. I didn't give you the root yet. The root is, so it'll look like this. It'll say 3/2 like that. So what 3/2 is 3/2 is a root. If you know it's a root, they're telling you it's a root. If you divide it in, what's the remainder going to be? If you divide a root in, what should the remainder be? 0, right? Now that's not our factor, and that's actually not important that we turn it into a factor. But the factor, if we wanted to make a note, the factor would be z minus 3/2. You don't need to know that in terms of turning it into a factor, but that's what we. So here, what our issue is that we have z cubed. We know that if we have a z squared, a z squared, a z squared, we can solve that. The issue is I don't have a z squared. However, when you divide 2, 1, -8, and 3, when you divide, you're always reducing, right? In terms of, we talked about that, you've been doing it with long division, synthetic division. When you divide z cubed, and you get out your new coefficients, z cubed turns into z squared. And so what you're actually going to do is you're just going to reduce this to a z squared polynomial and then quadratic formula it up from there and find the other answers. And something in 8.6 that we talk about is that if this is z cubed, you have 3 answers. They gave you 1, we're going to find the other 2. So you know it's 0 if you do your math correct. Why do you know it's 0? Because they told you a root is given. Anytime a root is given, the remainder is 0. So we drop that. We get 3/2 times 2 is 3, 4, 6, -2, -3, and 0. All right. So then, now that we've done that, we just created a new polynomial with a reduction of our exponents. So it was z cubed, now it's 2z squared plus 4z minus 2. And don't forget we're dealing with an equation, so equals 0. Like that. Okay, then from there, how do we solve? Well, you've got a quadratic. What are our methods? You could factor, which I don't think that's factorable. You could try. Or you could complete the square, or you could do probably the go-to is the quadratic formula. Completing the square actually wouldn't be too bad. I'm going to complete the square for us just as a form of review, even though most of you will probably do the quadratic formula, which is fine. So if you remember completing the square, you divide everything by the value of a, and then we are going to get our constant by itself. And then we're going to add b over 2a, but a is always 1, so b over 2 to both sides, 2 over 2. And then whatever is squared here, whatever is squared here goes into here. And then is equal to 2. And then z would be equal to a -1 plus or minus root 2. And I just took the square root plus or minus and then subtracted the 1 over and put it out front. And then that would be your other 2 answers. Quadratic formula is fine. Completing the square review works great too. So now you would say, okay, what's my answers? Well, I found 2 answers here, and then they gave you 1 answer there. So technically, z was equal to that. You would, technically say I have 3/2 like that. Those are your 3 answers. All right, then okay, I don't really want to take the time to do a full, I don't know if I need to do the full example on this. Because it's the same thing, but if you are given we'll call this number 4. Same thing, except we're going to say 2x to the 4th minus 5x cubed minus 11x squared plus 20x plus 12. And they give you, it's interesting, equals 0. What they just gave you on here is they gave you a quartic, so x to the 4th. So we had a cubic, z cubed. They gave us 1 root. We reduced it down to a z squared that we solved. If they only give you 1 root, you will take this x to the 4th and reduce it to an x cubed. Do we typically have issues in solving with x cubed? Yeah. Do we have any issues solving when we get to x squared? I mean, you may, but you shouldn't. You can solve. So, in other words, if they only give you 1 root, you're going to reduce it to x cubed, and then it would be cumbersome, it would be challenging, may not be able to do it, possibly. With a calculator, you could look for the x-intercepts, or with, possibly grouping, but they're not going to do that to you. What they're going to do is they're going to give you 2 roots, and the 2 roots are going to be, in this case, -2 and 3. So there's your 2 roots. All you do is you pick either one, it doesn't matter which one, and you do synthetic division. When we do the synthetic division, okay, you will end up with guaranteed a remainder of 0. Now, I'll show this, I'll do this work. So 2, -4, -9. Do this right, 8, -7, 14, 6, -12. Okay, so what we did that, we get out a remainder of 0. What we now have here is this, you could rewrite it, it's not wrong, it would just be excess notation, 2x cubed minus 9x squared minus 7x plus 6. That's what you,
yeah. Plus 7x.
Oh, plus 7x, okay. And then this would be, -14. Okay, and that would be still a positive 6.
Yeah.
Okay, so thank you. So plus 7x. So then here, because that would actually, that would definitely mess us up for our next round, is here you came up with a cubic. Do you just go into quadratic formula and solve? No, you have a cubic. Remember, over here you had a cubic, we divided, what did you end up with? 0. So we are going to do division again with our new coefficients. That's why you really don't need to rewrite it. You just take your new coefficients, would be here, and you would say, okay, synthetic division again with the 2, -9, positive 7, thank you, and then the positive 6. You know when you do synthetic division again, you better get out a remainder of 0, and what are we going to use for our root? Are we going to use -2 again? The answer is no, because -2 only occurs once. We are going to use what number? 3. But it doesn't matter which one you choose first. The coefficients would be different if you chose 3 first, but either way, you're going to get a remainder of 0, then you do it again. You should get out a remainder of -9, -2, positive 6. You should get out a remainder of 0, that's a -6. 2, 6, -3, -9, -2, -6, 0. Now you have 2x squared minus 3x minus 2 is equal to 0. Can you solve from there? Yes. Another one that they give you, same thing, except they would tell you like this, it'll give you this, and you're like, -2, they only gave me 1 root. But they'll say -2 is a double root. If -2 is a double root, how many times does it happen? Twice. So you would do -2 here, reduce it, and then you, instead of doing 3, if -2 is a double root, you would do -2 again, and then reduce it again. So in that case, you do use it twice because it's a double root on that. All right. you want to do? Let's do one last one, not like this, just going from roots to equations. I don't know, I may assign just a couple of these. I may adjust it. So find an equation with the given roots. So if you have, we call this number 5, what they're going to give you is they're going to give you a -2 and 3. Start with that. So they give you -2 and 3 as your roots. You actually did this like in whatever chapter that was, the previous one, chapter 7, I think, with the x squared minus the sum of the roots times or plus the product of the roots. But what they want you to do here is because they actually give you 3. Maybe we better do the full example. Let's tack on the third one. So what we do with this is when they give you the equation with the given roots and they want you to find that equation, what you do is you take your roots and turn them into factors. So this would be x plus 2, this would be x minus 3, and this would be x minus 2. And then since it's an equation, we can just say is equal to 0. So you take your roots, turn them into factors, and then you're going to FOIL them all together. Looks a little complicated because there's 3 of them, but you just take 2 of them. I would actually take these 2 and recognize those are a difference of squares. It would be x squared minus 4 times x minus 3 is equal to 0. And then distribute that in, so x cubed minus 3x squared minus 4x plus 12 is equal to 0. Just doing the distribution process like that. And then you'd be done. That's it. Okay. They make it a little more, some of it's a little challenging when they get the imaginary binomials. I think I'm going to skip those for you, so you don't have to mess with those. Okay, your homework will be, let's do this for this, remember this won't be due tomorrow. Tomorrow we're doing the MCA 8.1 through 8.4. This will be due